The idea of nuclear reactors on the moon might sound like something out of a sci-fi novel, but it's becoming a very real possibility, and sooner than you might think. As humanity inches closer to establishing a permanent presence beyond Earth, power is emerging as one of the most critical challenges. And while solar panels have their place, they simply can't meet the demands of long-term lunar exploration. Enter nuclear energy, compact, reliable, and capable of operating in the moon's harsh environment. But here's where it gets controversial. Does this technological leap risk turning the moon into a new battleground for global influence? In April 2025, China made headlines with its ambitious plan to construct a nuclear power plant on the moon by 2035. This reactor would support an international lunar research station, part of Beijing's broader vision for space exploration. Not to be outdone, the United States quickly countered in August when acting NASA Administrator Sean Duffy reportedly suggested that America could deploy its own reactor on the moon as early as 2030. While the rivalry between these two nations grabs attention, it's worth noting that neither side is starting from scratch. For years, both NASA and the U.S. Department of Energy have been quietly developing small-scale nuclear systems designed to sustain bases, mining operations, and habitats on the moon. This isn't just about planting flags or leaving footprints. It's about laying down roots. As a legal expert specializing in space law, I view this not as an arms race, but rather as a competition over infrastructure. And let's be clear. Infrastructure equals influence. A nuclear reactor on the moon may seem dramatic, but it's neither illegal nor unprecedented. In fact, if used responsibly, it could pave the way for peaceful exploration, drive economic growth, and serve as a testing ground for technologies needed for missions deeper into space. However, it also raises important ethical and practical questions about access, safety, and fairness. Nuclear power in space has a history dating back decades. Since the 1960s, both the U.S. and the Soviet Union have relied on radioisotope thermoelectric generators, RTGs, which use radioactive materials to produce electricity. These devices have powered everything from Mars rovers to deep space probes like Voyager. The United Nations addressed the topic in 1992 through a set of principles governing the use of nuclear power sources in outer space. Although these guidelines aren't legally binding, they emphasize safety, transparency, and cooperation among nations. International law doesn't ban the peaceful use of nuclear reactors on celestial bodies. Instead, what matters is how countries implement them. The first nation to successfully establish a reactor could set the tone for future norms and expectations regarding lunar activities. Under the 1967 Outer Space Treaty, which all major spacefaring nations have signed, countries are required to act with due regard for the interests of others. Practically speaking, this means that once a country installs a reactor, others must navigate around it, both physically and legally. In essence, such installations create de facto zones of influence, even though no one can legally claim ownership of the moon. Why does being first matter so much? Imagine a scenario where a reactor becomes the cornerstone of a large, long-term facility at the lunar South Pole, a region rich in water ice trapped in permanently shadowed craters. This ice is a game-changer because it can be converted into rocket fuel and life support resources. By securing access to these areas, a country effectively gains leverage over others who wish to utilize the same resources. Critics argue that this dynamic could lead to exclusionary practices, undermining the spirit of collaboration enshrined in the Outer Space Treaty. Some skeptics worry about potential risks, particularly radiation hazards. Even reactors designed for peaceful purposes introduce new environmental and operational dangers, especially in the unforgiving conditions of space. To address these concerns, The UN's guidelines include stringent safety protocols. If followed meticulously, these measures could minimize risks and build public confidence in the technology. So why choose nuclear over solar? The answer lies in the moon's unique environment. With virtually no atmosphere and 2-week-long nights, solar energy is unreliable in many key locations. Certain cracker-like craters near the poles never see sunlight, making solar panels useless there. A small modular reactor, on the other hand, could operate continuously for years, providing steady power for habitats, rovers, 3D printers, and life support systems. It's not just about surviving on the moon, it's about thriving. Moreover, mastering this capability is crucial for missions to Mars, where solar power faces even greater limitations. Rather than sparking alarm, this development presents an opportunity for leadership. The US, for example, could take the initiative by sharing its plans openly, adhering to Article 9 of the Outer Space Treaty, and reaffirming its commitment to peaceful use and international collaboration. Doing so would encourage other nations to follow suit, fostering a culture of transparency and trust. Ultimately, the moon's future won't hinge on who plants the most flags. It will depend on who builds what and how. Nuclear power may well prove indispensable for humanity's next giant leap. But building responsibly, within the framework of international guidelines, will ensure that we move forward safely and equitably. Is this a step toward progress or peril? That's a question worth debating. What role do you think nuclear reactors should play in shaping our shared future in space? Share your thoughts in the comments below.